So in this video I'm going to explain the solution of this Codeforces educational round 159 rated for division 2. So in this video I'm going to explain solution of first three problems. So now let's begin with problem A. The name of the problem A is binary imbalance. So what problem is said that we will be given a string S of which is containing only 0 and 1 letters only. So there is a operation defined to us. If you can see, I can choose any two adjacent index in my string, and if they are equal, I can insert one between them. But if the adjacent element are not equal, I can insert zero between them. So what problem is asking us to do is simply I have to tell them whether whether there are some possible number of operation in which my number of zeros would be greater than my number of one in my final string. So now I will tell you the intuition of this. So there are three possible cases in this question. First case is that if my all the elements are equal to 0. If my all the elements are equal to 0, this clearly my number of zeros are greater than number of 1 in my array. So in this example my answer is yes. Next example is like 0 0, which means there are some number of zeros and some number of ones in my final array. Suppose you can say in this case my number of ones are greater than my number of 0. Okay, but you can see if there are zeros and 1 in my array, there should be at least one adjacent pair in which my one element is 0 and my another element is 1. Because you can see if my adjacent element are not equal, I can simply insert 0 between them. There is a possible operation given to us. Okay, here you can see. So if I'm choosing this indexing pair 0 and 1, I can simply insert 0 between them. So by inserting 0 between them, I will get a final string like this. Okay, so number of ones again. So you can see there's another pair of 0 and 1. I can again insert 0 between them. So by using this pattern, you can see I can insert infinity times of 0 in this array if there is a single pair of 0 and 1 in my final string. So you can see in this case my answer is always 1. Also yes. But you can see I can always increase my number of zeros. The answer is 1. Now the last case in which my all the numbers are equal to 1 only. So you can see there is no pair in this array which are not equal. The for checking the every adjacent pair, I will always get the both the equal numbers. Okay, if I'm getting the both the equal numbers, I can only insert one between them. Which means if my all the elements are equal to one, I can simply increase my ones to more number of ones. I can never insert a single zero in this operation. Which means in this operation or in this type, my answer is never existing. So the simple code would be like this only. If my containing all the ones, if my string is containing all the ones, then my answer is no, as my answer is yes. Okay, so now let's begin the problem number B. So the name of problem is B is getting points. So what problem is said that there is student named Monograph, and okay, and uh, he is currently joining a university, and what they have said to pass the, or you can say to not getting expelled, he should have at least P points. For example, but they have said to not getting expelled, Monograph should earn at least P points during the end days. And what they have said how he can earn points is that if he is attending the lesson on the ice day, he will getting L points, and there is another weekly task. If he continue the weekly task, he will get the T points. But there is no condition that he have to complete the practical task on the day given to him. He can complete the task in the future also. And you can see if the monograph is going on the first day, he will be getting one practical task and one lesson. And you can see the lessons are not short, which means he have to attend the lesson on the day he's attending the college or he's going to college. If he is not going to college, he can never attend that lesson on the next day. But there is a case with practical task or weekly task. If he is not completing task on the day it is given, he can complete the task in the future also. Okay. For example, in this case, you can see on the first day he will be assigning one weekly task, and the next weekly task will be assigning on the eighth day. Okay. So now what is a problem asking us to do? I have to tell them what is the maximum number of holidays which monograph can make so that he is not getting expelled from the university. Which means if he is taking the day off, he will not attend the lesson, and he will also not do the weekly task. But if he is going to college or he is doing the work, he can also attend the lesson and get the L points, and he can do at most 2 practical tasks pending to him, and getting that and get 2 points for the each task, each weekly task. So you can see, for solving this problem, you can see you can use a simply binary search. So if I show you the why, you can see the what is the minimum number of holidays which he can take. The minimum number of holidays which he can take is 0, and the maximum number of holidays which he can take is n only. So I will simply run a binary search in this range only. So by using binary search, I will get a middle value, and by using that middle value, I will set that is the number of off, or that is the number of holidays which monograph can take. Okay, so the number of holidays which can take will be middle value. Okay, so let's suppose it is off only. So off is the number of days which he will make the holiday. So if he's taking half day offs, then the number of working days would be so let's suppose W is the number of working days. So number of working days would be n minus number of days he is taking the off. So number of working days would be this only. So by getting the solution, I will tell you one explanation. For example, if this is a timeline of the monograph, this is 0th day and this is the nth day. So I will tell you the monograph would take the off in the starting only. This is a number of in which monograph will do no work. And what is the number of day? What are the days in which monograph can do work is the last days only. Because you can see there's a greedy approach in here. For example, you can see monograph can do at most 2 practical tasks on the ith day, on the day he's doing the work. So I will try to do a thing like this. If monograph is doing work on the ith day, he should have at least 2 practical tasks on that day. And to accumulate 2 tasks on that day, I will try to skip the task in the starting days. For example, this is the task, this is the day in which he's given a task. This is the day, this is the day in here. So these are the total number of days in which he is not doing any practical task. So at the end, you can see if monograph is coming to first day college is this only. Okay. You can see by coming on the this day, he will be getting these number of weekly tasking already, which means he can use that day to his max. You can see to use that day to his max, monograph can attend a lesson and get the L points. Plus, he can do 2 practical tasks on that day also. So I will always try to do earn these number of points on the day he's working. Okay, so this is option number 1. So now let's begin. Now let's get to a point back here. So you can see if monograph is working W work, if monograph is doing work on the W days. So what are the number of lessons which he will attend? Are W only, which means I will simply add W into number of lessons, the points for each lesson in my final answer for the current day off. So you can see here. So you can see what are the number of practical tasks he can complete in the W days. So you can see in the single day he can do 2 tasks. So the W day he can do at most W not 2 tasks. But there is a condition. What if my task is not here only? So what is the minimum number of tasks assigning to him? So the minimum number of tasks will be n by 7 only. Okay. Which means is the total number of tasks which will be given in the timeline of the n days. And what is the maximum number of days he can do is W into 2 times. So the minimum both these would be the number of tasks he can do in the W days, and I will simply multiply it with t only at the end. So you can see by adding these equation, so adding these two equation, I will get the number of points the monograph can work if he is taking the off days off, these number of days of holidays. Okay, so I will in the end I will simply check whether the answer or the number of points are greater than or equal to points which are required. If this condition is true, I will simply turn my search space to this part only, because I have to increase my number of days off. So if on the this day if on the this day I'm able to get the number of sufficient point, I will try to increase my number of days off. Okay, okay, but this is the condition number 1. What if on the this day he is not able to get the enough task? So if he is not able to get the enough points, then I will turn my search space to this part only, which means I will decrease the number of holidays. By decreasing the number of holidays, my number of points would be increased. because you can see that my number of days off are inversely proportional to number of working days. By decreasing the number of off days, I will simply increase my working days, and hence I will increase my points also. So by using these simple equations, I can find the maximum number of off he can take in this entire session. So if I show you the code, first of all you can see I'm simply setting the maximum and the minimum limit. The minimum number of holidays are 0 only, and the maximum number of holidays are n only. And because you can see here, I'm simply calculating the mid value, which is the number of days he can take off. And this is a simple function which is telling me whether taking the off in the mid number of days, whether I'm able to get the p points or not. If I'm able to get the p points, I will simply increase my number of days off, else I will simply decrease my number of days off. Or what is a p function? You can see p function is like this only. I will simply calculate the number of working days. Okay, then I will calculate the what is the maximum number of tasks which he can do in the time span of n days. In the time span of, okay, this is a useless equation. So then what I will do, I will simply calculate the number of lessons he can attend in the working days. So this is a total number of working days only, because every day he is getting a lesson. So the number of points will be working days into lesson. So what is the next? Next I will calculate the number of practical he can do. The number of practical he can do will be working days into 2, comma, minimum of the maximum number of tasks he can get in the end days, and in the end days, in the semester of end days, and simply multiply it with t, which is the number of points he will getting for completing one task. So I will simply done one if my current number of points are greater than p. So if it is greater than p, I will simply increase my search space, else I will simply decrease my search space to mid minus 1. And for this you can see I am ensuring that I am getting the maximum number of days off for the monograph. So this is a problem number B. Now let's begin problem number C. So the name of problem is C, insert and equalize. So what problem said, we will be given a array A of n size, and initially all the elements in my array are distinct. And what they have said, I have to add another number in my array such that that number is not present initially in my array. Okay. Now what they have said, after adding that number, I have to choose another number x, and I can simply add x in any number of times. If I am choosing a number as x and index is and second index, which means I can add x any number of times in my second index. And you can see what problem is asking us to do, what is the minimum number of operation I can perform so that all the elements in my array are equal, including the last number which I have added. Okay, now I will tell you its intuition. So first of all, I will debug the first some sample test cases. So that some first test case is 2 3 1 2 3. So let's suppose I'm adding 4 here. This is a number which I have added. Now the x which I'm taking is 1. So what is the minimum number of operation on the I can I can perform on the one, so that all the elements become equal. You can see there's a single operation in which I can only increase my number. I can never decrease a number. Okay, so this is the case. I can never decrease a number. I can only increase a number. So which means I can never decrease my smallest number, or I can never decrease my largest number. I can only increase my smaller number. Which means I will always try to make all the elements equal to the largest number in the array. To make the one equal to the largest number in the array, I have to use at most 3 operation for x is equal to 1. And to make 2 is equal to 4, I can use 2 operation. And to make 3 is equal to 4, I can use 1 operation. So the total number of operation I am using is 6 only. So the answer for this sample test case is 6. Okay, you can see here. So now I will tell you the second test case. So the second test case is 1 minus 19, 17 minus 3, and last is minus 15. Okay, so we can see in this case my largest number is 7 only. Okay, so now I will always try to make all the elements equal to 17 only. Okay, so to make one, so what is the difference between 1 and 17? So difference between 1 and 17 is 16 only. Okay, the difference between minus 3 and 17 is 20 only. And the difference between 17 and 17 is 0 only. And then you can check the difference between minus 19 comma minus 15 is okay, minus 17 is 36. It is 36 only, and the difference between minus 15 and 17 is 32. So you can see there's an observation. What is the observation? You can see my all the number here are divided by 4. So this is a 4 divided by, the 4 divided by 16 is 4, and it is 9, 0, 5, and 8. You can see I can make all the numbers equal to, so I can add some specific number of 4 in my all the elements, so that my all the elements can become equal. So what is the number I can add in the end? So the number I can add in the end would only be equal to 17 minus 4. By 17 minus 4 I will tell you again. So I will simply add 13 here. You can see I will simply add 13 in the end. So you can see what is the x. I can choose x as a 4. Okay, I will choose x as a 4. Now I will simply do the sum number of the I will choose x as a 4. I can I can perform the operation 4 times on the first element, 9 times on the second element, 0 time on the third element, because it is the largest only, and at the end I'm only trying to make all the elements equal to 17 only, and 5 times on the 3, 8 times on the minus 15, and one time on the these three. So the addition of all these will be equal to 27. Okay, 27. Because you can see there is a conclusion here. The conclusion is that only I will always try to make all the elements equal to maximum number in this array, in the every array, because you can see I can only increase my number, I can never decrease my number. So by using this conduction I can simply tell you that I will always try to make all the elements equal to maximum number only. Now next point, I will calculate the difference between the maximum number and the every other element. Okay, I will calculate that part also. If there is a single number, if there is a number x which is divisible by all these number, which means in short I am calculating the GCD of this difference. So GCD of this difference would be 4 only. Okay, so if I calculate GCD of the differences from the current number to the maximum number, I can tell my x would be GCD only. My x would be GCD only, and the number of operations which I will require would be the current number minus the maximum number divided by GCD. So by using this formula, I will calculate the number of operations I can use on the ith element to make it equal to the largest element. Okay, but there is one case. What is the last number I should add in my array? So what is the last number? You tell me. Wait a minute. I will tell you only. You can see the largest number, the number which I am trying to make equal all the elements equal to the largest number in my array. The GCD is that number which is divided by all the differences. So I will simply subtract the GCD from my maximum number, and I will keep on subtracting the GCD from my largest number until that number is not present in my array. Because you can see if if the 13 if 13 is already existing in my array, I can never add 13 at the end. You can see I can never add 13 at the end. Then you can see I will again subtract GCD from my 13. That is equal to 9. You can see the 9 is not here. So I will simply add 9 in the end. So this is the number which I will be adding in the end, and the differences and the GCD of the differences of the number from the maximum number would be my x. And by getting these two values, the finding the answer pretty much easy. So if I show you the code is also easy. First of all, what I'm doing, I'm simply sorting all the numbers. Okay, we can see now next I'm taking the maximum number in my array and subtracting with the second maximum number, which means in short I'm calculating GCD of my whole array with the difference with the maximum number. Okay, now my GCD is this only. By using this, you can see I will calculate the number of operation. The number of operation required would be the current element minus the maximum element divided by GCD. Here GCD is x, which I am adding in all the elements. I am again telling you why. So you can see I will simply add that number. So what is the last number? Which is the number I should add in the last? So the number which I should add in the last should be a divisible of GCD only minus the maximum number. So I will keep on decreasing my maximum number until my number is not there in my array. So I will simply maintain a map for finding that number. So if that number is not present in my array, I will simply add the, because you can see, if I'm adding 9 in the end, I have to also make 9 equal to 17 only. Okay, so the what number of operation are 17 minus 9 divided by GCD, or I can say X only. So I simply add that number of operation also, and I simply print the answer in the end. So this is a problem solution of problem number C. So if you like the video, please don't forget to subscribe my channel. And if you have any doubts regarding these three questions, you can comment me down. And please don't forget to subscribe my channel. Till then, stay tuned for the next one. Thank you.